Oh, it's length at least one. So if there's any duplicates, then uh, that would be a cool subsequence. So 2 would be a cool subsequence. Uh, what if there are no duplicates? If there are no duplicates, can I assume that there's no cool subsequence? 1, 2, 3, 1, 2. Right? It's not possible. M is equal to n. All the elements of A are distinct and the elements of B are distinct. That is n. Okay, non-option is the following. Choose a subarray of A length m and replaces the cycle rotation of the array B. Since okay, first nm nm. Okay, so in 416 I'll have to replace this with some permutation, some slight rotation. This is just 2, so 4 cells into 2 to 2. This can be better. So 2 1 2, and you have 1 2 3 4. No, none of it can match 1, so I'll leave it. None of it can match 2, so I'll leave it. Some of it can match 3, but can it? Is there anyone which beats 3 4? If yes, then okay. First, I'll have to find lexicographically smallest rotation of B. So this is 3 5, and this is 3 6 4. So it's unique. Now, since that's unique, I just have to see right. So if it's unique, then so let's say I do 3 6 4. Then it's better to do 3 6 4 here again, since it will always be better than this. And I keep doing this until I reach the end. So it's going to be regular A, then 3, and if it beats, then continue, else it's just going to be 3 3 3 3 and then 6 4. Let me just confirm. So you have 2 3 6 4, right? So how do I formalize it properly, since there might be many arrays where it matches? So what I would do is consider if all are less than or equal to, but might not be close to. So it's guaranteed that the permutation of B would be strictly greater. So whatever starting here will be continuing, but in case of A, so if you have 3 and then a drop, then no, right? So check first char greater than B0, either start there or yeah, it's always start there, because anyway it's 3, it's same as starting at the next one. Perfect. Or start to the left if no space left. So might be better start on the left if there's no space left. So I can consider the first car greater than 3, so let's say 6, but I don't have much space. So what I do is, so I don't have much space, then this suffix isn't suitable. I think that's a separate edge case, because that won't be 3, which will be singular, it will be something else. So that's just a case I'll consider if putting the prefix, if putting it as a suffix would make a difference or not. So this is a separate case. So what I've discovered till now is this: find the first character greater than P0. That's our starting. If the space is too less, then check if replacing suffix works. If not, return. if you have enough space, then keep a string of b of zeros and have b at the end. So you have a and b, and now put this in a deck. Cool, so we have been the most epic one. Now int index is equals to -1 for int I is equal to 0, I less than n, I plus plus. If actually, let me just check if I plus m minus 1 is less than n. So if v of I is greater than b of I, index is equals to I break. If index equals to -1, else. So let me just do where alternate. Actually, no, this is cringy. I'll just make separate cases. So alt is equals to v. So for int I is equals to I plus m minus 1 is equal to n minus 1, then I is equal to n minus m. Plus alt of I is equals to b of I minus n plus n. So variant is what's smaller, else for int I is equal to index I plus n minus 1 is less than n, I plus plus, v of I is equals to b of 0, and then do the same thing. Okay, that's only true if uh, its length is greater than 1. If m greater than 1, else in a x equal to start min a x comma b of 0 output a. Should have tested, but YOLO. Cool. There are n empty seats in a row numbered 1 to n. And introverts arrive one by one, choose a seat for themselves. Being introverts, they have some rules to minimize contact with the primary goal. The person will aim to maximize the chosen decision from the closest occupied seat. Secondary goal, if in case of multiple seats satisfying the current goal, person will aim to choose seats that the next person will arrive will have a higher distance from the closest expected seat. That is, a person aims to help the next person meet the primary goal better. I don't understand shit. In case multiple seats matter for both goals, tries are broken arbitrarily. Formally, if the set of occupied seats number S, the seat numbers is set U. Primary goal, choose X as to maximize X minus U for all I in occupied sets. Secondary goal, let's see denote the X maximizing min of let's see on the set of all X maximizing min. Choose any y in C such that the min of I given S including U over all X is maximized. Okay, so the distance for the next person is maximized. If we denote Pi to be the number of persons sitting in seat number I, and P is equal to permutation, right? Given permutation from 1 to n, determine if it's possible for n introverts to seat themselves according to the rules above, such that the final arrangement forms a permutation P. Okay, given the permutation P, and we have to see if this satisfies. Oh, is the order not arbitrary? Okay, its orders are fixed. So I just have to say that if this works, if this follows the condition, thank God. Let me see. I doubt if this is the easiest problem left, but two submissions. Let's see. 2-1. Yeah, first one, both C's, both goals, you can choose 1 or 2. So perfect, that works. 1 4 6 1 4 3 6 5 2. First person can has to choose the ends. Yeah, he has to choose the end. Second person has to choose another end. Third person, does he have to choose that? I can choose sit in seat 3 or seat 4 to fulfill the primary goal, as both have the highest closest distance to another person. Distance is 2. Okay, I have to highest closest distance, not highest distance. Okay. Maximize closest distance. Okay. Let me work this out on paper. So let me analyze this case. You have 1 because endpoints first. So here the max just in this turn, let's quantify a term called max dist after every turn is what? Uh, n minus 1, so 5. Then for 1, so for 2, if he comes here, the second person will have a min dist of 2 always, but if he goes here, then the second person can go here, or which would say the distance is what, 3 and 2, or I can go here, which is again a distance of 2. Yeah, so 2 and 3 will choose this or this. So you can choose this. 4, well, is this choice better than these two? So if he chooses here, the other person has a min distance of 1. If he chooses here, other person has a min distance of 1. It doesn't matter, it's arbitrary. So 4, 6, 2. If one choice is arbitrary, is everything else arbitrary again? Again, tough to know. I guess this is not optimal. So since 4 and cool. So 1, 2. Now 3 must choose so that 4 has a good chance. So according to this, 3 has chosen this. Now 4 can go here, which would optimize 1, or 4 can go here, which would make the min distance 2. But if 3 would have chosen this, the min distance would be 1, which is worse. So 3's choice is good, and 4 can choose here, which would make it 1, or here, which would make it. But 4 will first choose his best. So 3 also should choose their best first. So 3's best choice would be here, and if there are ties, he would think about that. So 4's best choice is, yeah, 4 has to choose somewhere. So it gets wrong because of 3. Is that what the explanations say? Okay, so at first turn you have many options that satisfy 1, but only to satisfy 2. At second, you can only choose n. At third, if odd, you choose center, or you choose adjacent to center. If even, any two centers. And if it's 4, if 4 and even, you choose centers of the guy. So it's always choosing centers. So for 1, you have 1, 2, 3, 4, 5. So at the end, if there are many centers, are all of them valid? Yes, I think so. So consider this case. 1, 2, 1, 2. So 3 can choose anything. 3, 4 is what? This or this. So you have 1 here, 3 here. So you would choose this or this. Actually here, it's not necessarily choose a bigger one, because here the distance is 1 again from the closest one. Let me look how the array changes, which maintains the distance from. So in case of 6, so you have 1, and then this array is what? Uh, 1, 2, 3, 4, 5, and then in the next turn, 4, 5, 6. So the next turn, you choose 2, and this becomes 1, 2, 1, 2, 2, 1. So you have two options, anything would work. So he chooses 3. So he chooses 3 here, and this becomes what? 1, 1, 1. Now all three equally probable. And say they choose, so if he chooses this, then this becomes what? This remains 1, 1. It doesn't matter. If he chooses this, it still remains 1, 1. But it actually doesn't matter. 3, 4, then 5, 6. So once you reach ones, once you reach ones in the distance array, you'll any choice of numbers will work. So my claim, just checking for first condition after first choice is optimal. Consider a 8. 1, 1, 1, 1, 1, 1, 1. So you have 1, 2, say I choose this 3, 4. So here that's like 1, 1, 1, 1, 2, 1, 3, 4. Now everything else doesn't matter. I just maintain a priority queue. So I have a big one. So I choose what? 1, 2, 3. Now this is analogous to a problem of 1, 2. This is analogous to a problem. This. Neither way you do 4. Doesn't matter. Yeah, I think it doesn't matter. As long as I'm picking the max distance, it doesn't matter. So I just maintain what's the max distance now. How is that trivial? So what? 5, 2, 1. And 6. One, two. So what's the distance? 3. Yeah, 6, 3. One. So binary search and check if closest is but yeah, you can have multiple of that. So for example, you have 1, 2, 3, 4, 5, and you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, whatever. So you have 1, 2, 3, 4, 5. So here, so for 2, so you have 3, 6, 9, 11. So for 2 the distance was 10. Next the distance was what? 3, 5. And then the next distance was supposed to be 2. So 1, 4, 2. But it can remain 2 for a while. So it's what? 5, 2. In case of 5. So you have 2 and 1. So you have 3 and 2. Now let me tackle systematically. So you have x and then y. Their difference should be at most what, 1, and right. So if I have a boundary points of length 1, 2, 3, 4, 5, 6, this would lead to boundary points of length 3 and 4. So 4 would lead to a boundary points of so technique, this is important. So for given n, what is max dist? if n is odd, so you have this, some t, you have boundary. So distance is what? T plus 1, and n is 2t plus 3. So what? N minus 1 by 2 if n is odd. So symmetric. If it's even, so you have b, let's say this is t x b. This is the small distance, and that is what? T minus 1, and n is 2t, which should be n minus 2 by 2 if n is even. So you have minus 2 by 2, you have 1 of n minus 2 by 2, and you have 1 of n by 2. So I keep bumping it and get the largest out. That's for generating one, but what about checking? So for checking, I just have to, see length of interval, and if f of length matches bestance, if yes, then erase interval and pop children. If children greater than 0, wait, when odd, min dist is n minus 1 by 2, but children are length t plus 2 comma t plus 2, which is n plus 1 by 2, and here the children's are of size t comma t plus 1, which is n by 2 comma n by 2 plus 1. So to summarize, odd dist is n minus 1 by 2. Child is n plus 1 by 2, n plus 1 by 2. Even dist is n by 2. Children are of length the distance is not n by 2, distance is t minus 1. This is n minus 2 by 1, 2, and children are of length n by 2 and n by 2 plus 1. Push children of length 2. Cool. So I keep doing that and then just check. So 2 is current. So set int s. Let's start insert n. Int x fix and 1 else fix and 1. Then the dist is n minus 1 by 2. Return x minus 2 by 2. Auto children int x and 1 else the should be a multi-set. Chosen is indices of I. So how to get bound? Int x int lb is s dot int ub is s dot upper bound x auto lb is start pref return start make pair lb ub indices chosen is indices of I. Auto l comma rs get bound in chosen debug in chosen comma lr. Now what I need to check is, okay, is it ball is greater? So if I have 5 4 6, this is what 2, this is 2, this is 1. Okay, this one 2 minus 2, so perfect. It always remains the same, it's increasing. So auto big is s dot r begin if int cur size is r minus l plus 1, if dist big is equal to dist cur size, then it's suboptimal. Return. Then it's no, and so now we know it's equal. So then I just s dot erase s dot find big, so just one item that's being removed. Auto c1 c2 is children of big, actually no, cur size. If c1 is not equals to 2, then s dot insert c1. If c2 not equals to, s dot insert c2. So if it's complete all this, then output yes. Compile D 176. This is I have to insert it. Four, 2, 3, 4. Six. No, you have 3 and runtime error. And 4, 4. That's true. Let me just stress. So 13542, I'm getting this. Cat T1 of biggest 3, curve size is 4 and it's not there. Why? So 3, 1 to 3 is 3 and 3 to 4 is 4 minus 3 is what? 1, 2. Five. What's the dist? Uh, Okay, cool checker. Pritesh was assigned to write the checker for the problem pool subsequences. He found this an interesting problem on its own. You are given two arrays A and B, both of length n and m. A non-empty subsequence of A is said to be legal if average of S is in B and average of S is in B, and average of S is average of limits in. Note that no rounding is done when computing the average. For example, the average of 1 to 5 is 8, so 8.0 and round to 2 or 3. Okay. So all integers. So find if any subsequence of it that is not legal. Notice I'm not going to find any of them. Okay, we're going to find if not legal. So find a sequence where, okay, is school checker still the best option? So you have A, B, boom. A, B, boom. And you have B, boom. So here the option is 5, here subsequences 7, 8. Here the subsequence. There's no bad one. So sample test cases a week. If an array is big enough, can I guarantee that there would be a subsequence such that their average is a floating point? So one counter case is when you have all equal. So but if let's say I want to play with parity, so if there is some odd and some even, then so 0 1 minus 1 minus 1 minus 1 1. So one count parity of 2. So 0 1. You have diff at least 1 in both, then you have a case. Parity with Lexicographical 3. So you have 0 or divisible 1 and 2. So you can take 2 here, take 1 here, or take one of each would be bad because that would be divisible. So I would take 2 of these, 1 of these, 2 of these, 1 of these, or 2 of these and 1 of these, 1 of these. Then parity mod 4. So if it's past this, then all odd or all even. And if past this, so thing is, if n greater than equal to 3 and either you have 1 which is 0, 1 which is 1, 1 which is 2, or you have all 0 0 or one of these permutations. For 4, it'll either be spread between 2 and 0 or 3 and 1. So if I take so 3 is just what, -1. So if I take equal of these, that would be divisible. But if I take 3 of these and 1 of these, or 1 of these, 3 of these, then I would have a case where it wouldn't be divisible. Or same with this, 3 of these, 1 of these. You have 2 and 1 0, so that's still mod 2. So you have 17.7 in max product partition. How much does even value have? These 4. Either way, so let me take an example of each of the parity. So if passes 1, then all in A exists in B. Is there any condition on length of n and m? No. Yes and B. If it passes 2, all odd or all even. If it passes 3, then so let's take this case. So let's say 2 is what? Let's say it's at least what 1 3 5 69. Now this is, or it is 2 4 6 32. So modulo 3 is what? This will be what? 2 mod 3, this will be 1 mod 3, 2 mod 3 and 2 mod 3. So I can take this and this wouldn't be an integer at all. But what would be the cases when it's all 1? So for example, plus 1 and 5, 10 is 2 more 3. Or no, 10 is 6 plus 2 or 8. So in this case, if it's 286, so B has to be 28632, and for the averages should be there. It's 10, 5, 14, 7, 19. Right, point is it becomes very big. B becomes big very fast. If true. Are there any conditions on them being distinct elements? No conditions. So I can maintain, right, maintain frequency map of A and B. I can check with brute force, since if so if 2 passes, then you have n and then root n. If 3 passes, but how many of them will have distinct values? So you have A1, A2, A3, 4, and B1, B2, B3, B4. So they all, so either there are only 3 elements, so either there are only 3 elements, and all this one of 1 1 0, 1 1 1 1 2, or they're all same modulo 3. If they are same modulo 3, then does that help us in any way? So if there are all 3k plus 1, then I know they are odd. Five additions would still make it 3k plus 3k plus 2. So let's say you have 2, uh, 8, 14, 6. So same modulo 6, same modulo 3. If no 4, so let's say you have 0, 1, 2, 3. So if I have 2 plus 3 plus 2, 4 sun. What's the maximum number of identical sums possible? So I'll take at most 3 of them. So if I'm testing for k, I'll take at least k of each of them, and then would check this and permute to all k versions. It looks like implementation hell. Is there a binary number trick? Or should I just do recursion? Alright, I can have a boolean array and visit all permutations of it. I'm doing in cube. If length is 0, then I should have been the subsequence. If I0 I less than n, if vals of a of I, then ans dot pushback a of I, vals of a of I minus output ans Now if that tallies, I will try checking the inverse also. Wow, that worked. Postman and LLM, volume minimization. Number line sign on 0 and extended infinity in this line. The n houses, the ith house select industrial di is a postman who can deliver two m houses. The postman on the son receives first m into x's, the house assigned to him. The legacy index is favorite LLM, asking it what he should do to make these deliveries. Unfortunately for him, the LLM has malfunctioned. If he asks these questions to the LLM ends up the random permission people in them, which describes the order in which he must make the deliveries. After he receives the permutation, he goes straight DIP1, DIP2, DIP3, DIP4, and finally just DIMI for assist. Distant polar matter equals the manager distance. You being the nice manager you are, you feel bad for the postman and know the plan. Therefore, expected. Therefore, you decide to assign him houses so that distance he is expected to travel to LM is minimized. Let the minimum stands. Furthermore, you are curious about how many ways you can assign houses to him, so chance is still minimized. That's it. Minimum value stands. Furthermore, is and times m is always an integer. Okay. So you have sigma answer times number of ways you can give him divided by total number of ways. Total number of ways is NCM, which is in factorial by factorial, but that times m is always an integer. Interesting. Two assignments are different if they exist a k such that I cannot check k first and input containing rigidity. This seems hard. So I can maintain this just making a range space structure such that you have this answer, now you want the answer for this. But again, I think I'm better off doing the probability one since it's more closer to my expertise. So he has to travel him. Are there any constraints or sum of n? So you have DIs and VIs. Now, what's the expected given an index set? What is the expected order of expected value of the total distance that a tracement will contribute? Well, it is di. So it's at any point you would cover this. That's the distance of the smallest to biggest. Upon that, there are some overlaps. This is interesting. So you have d1, d2, d3, d4, d5. I mean, let's consider d1, d2. You always have just this, no matter what permutation, right? Just want to make sure I'm targeting the easiest. One, two, three, 6, 7, 8, 9, 12, 13. Postal limb, okay. So you have d1, d2, d3, d4. So you have this distance, this distance. So let's say you have 1, 2, 3, 4. So you have this. Now say there's a switch. So you have 1, 3, 2, 4. So you continue to have this, but with this switch, you have added this. So 1 to 2 is still the same, but you have added this extra term. So this is going from 1 to 2 and this is going from 2 to 3. Now if I make another switch, let's say between 4 and 1. So now I do, so I just start from 4. I think 1 to 4 switches are, for lack of a better word, symmetrical. But I think 4 is still a bit complex case to analyze. Let me start analyzing case of length 3. So you have 1, 2, 3. So you have 1, 2, 3. So you have what? 2 minus 1. So that's 1, 1. So when you have 1, 3, 2, you have 1, 2, 3. 2 and 3 to 2 as 1. Actually, I will continue to keep this same. I would say this is 2, 3, and this is, now this has become 2 and this has become 1. Then you have 1, so 3, 1, 2, 1, 2, 3. So based on starting point, assume starting point to be the same, just a flip. Now if I analyze 1, 3, 4, so you have 1, 2, 3, 4. Actually, I can analyze those cases, that's not a problem. So if I do 1, so 3, 1, 2, I mean, if I go in lexicographical order, you have 2, 1, 3, 2, 3, which is what, 1, 2, 3, and you have 3, 2, 3, 1. 3, 1, 2. And 3, 2, 1. Now here it's what? 2, 3, 3, 3, 3, 2, 5, 8, 11, 14, 16. So 16 by 6 factorial. Wait, no, something's off. By 3 by 6. 3, 4, 12. So on average, I make a distance of 3. But does graph help? So what happened when I went from this and made a switch? When I made a switch, basically, just went to M1. Point is, why is ans times m an integer? So answer is going to be of the form some number divided by n choose m times m factorial. Now you're saying that this times sigma number times and choose m times m is an integer. No, what he's saying is consider min number. Let that to be ans. So ans has some number of ways. Now ans and ans is a fraction such that ans times m is an integer. How? Can I say that this plus this plus this plus this will result in a valid path? So let's say you have 1 1 2 2 3 3 4 3 2 1, right? That means I go here, then I go here, then I go here, okay. No, house numbers. Are the house numbers in increasing order? Even if not, I can sort it so that it is in increasing order. But my point is, he's going to go from some house, visit that, then visit this, then that, and go to the last house. Is there a necessary and sufficient condition for such a distance array? Is what I am trying to find. So, if he's going to the last left end, then this length will always be greater than equal to 1. And then if he moves back to the right by some steps, he's adding 1 to this segment. So 1, 1, 1, 1, and then later the answer is just sum of values. So when, let's say, you have an array of length 4, so let's say this is a starting point. So when he goes here, he's adding 1 here, so it becomes this. When he goes here, he's adding 1s here, so then becomes this. So but we have to be careful with visited. So this is visited, this is visited, and this is visited. Now he can go here or here. So if he goes here, then 2, and then So it's 1. If it goes here, then 2, 1. So the total distance of 3, 4, 6. What's the pattern? Either way, the contribution has to be if it takes each one and goes, or if we skip some, it's the same necessarily. But at the end, I'm basically adding ones of a certain length. So if all the uh, distances are all just consecutive, then what is the expected value of traversal? I have to check this out. So wait, let me do it using brute force. So vi pum is vi of n comma 0 start iota all back pum comma 1. Who cares? Do while next using back is equal to long using third map big talk, right? So big what's a dist? Big dist is equal to 0. Get inverse. Photo album now then find the expected value, which is That's true. 8 0 1 2 8 20 40. what 0 2 8 20 40 70 1 1 2 6 8 2 40 3 30. 2 14 32 18. We have what 4 5 6 7 8 9 10 11 2 3 3 4 5 6 7 5 6 7 8 9 10 11 12 13 to 17. And you have 2 4 16 2 4 18 40 2 4. हाँ contest అవుతుంది and 13 minutes. Is there any pattern that's emerging with number of ways contributing to each? So it goes and increases. So you increase linearly. 8 9. Some of them are powers of 2, some are not. What I don't understand is why is sixteen. I don't see any pattern of easily guessing the thing. Neither do I have any model which would estimate the expected value for a particular subsequence. Best I would do would be to choose distance such that the max dist is minimized, and if there are multiple then do something. But even if I chosen, if I'm asked to find the expected value, it seems I don't have an idea. There's 10 minutes. My rank's 51. How are there 44 submissions? I don't know, I can't see how. Let me try this. given an array of length n, every element is 0, 1 or 2. Like. So if it's the same modulo, it's just as good as deleting. If it is 0, 1, then it's keeping one of them. If it's 1, 2, it is putting 0. If it is 2, 0, it is keep. So if it's 0, just deleting 0. If it is 1 or 2, it is deleting both and putting 0. So either put a 0 or I put a 2. So choose an index as another opportunity to say by 1. Let f is the lexical minimum possible array that a can be transformed into, or the defined value to be the ternary value of a. Formally that your task is to compute the summation of ternary values of all a. So if it is 0, 2, 0, 0, 2, 0, max I could, if there's a 2, 2 somewhere, then I could make that 2, make this 2, make this 2, make this 2, and then make this 0, 0, 0, 0, and then a 2. Okay, I can probably use the fact that, so T1, T2, T3, T4, T5, T6. So these are, so you have what, 0, if there's a 1, 2 somewhere, I can make this delete all. Okay, if all ones, then reduce to 1. If all zeros, reduce to 0. So if all x, so if all x, then it's just x. If all if you have some arbitrary thing and you have a 1, 2, then, so if you have a 1, then you delete this one. If you have a 2, then you look forward. So if you have a 2, you delete the 2. If you have a 1, then you look forward. If you have a 0, delete that 0. Keep doing that until you reach the end. Then you will have 1, 2, 1, 2, 1, 2, 1, 2, something, right? And assuming we've deleted all zeros up to this point, so then this can be 0, this can be 0, this can be 0, this can be 0, and then what I can do is delete all these zeros, leading to only some number here. Perfect. Now if it is 0, 2, then if it's 1, 0, 2, then I would delete this 0 and keep this. If it is 2, 0, 2, then I don't know what to do. Let's say it's all 2's here, delete the 2. So if it's 1 here, then I found a 0. When I make these into zeros, then I can reduce all this into 0, 2 and keep it. Never optimal. This is never optimal. If I get a 1, 2, always better to reduce only after deleting the duplicates. So first my job would be to delete dupe, and so leading to 1 2. So if there's a 2 or a 0, if I had counted to 0 already, then it doesn't matter. So first operation is delete dupes except zeros. Then so if I have 0, yeah. So if I have something like this, then don't bother. Oh wait, two twos make a 1. Otherwise, it seems like I don't have much time, so might as well explain the solutions a bit. So I'm surprised when people could solve the LM question. I don't think it's a trivial. So A is trivial. So y is number of y is the penalty and x is the time. So y plus 10 times time. When B is forgotten the question. Right. So I just have to get a case where it's not possible. And I can find a cool subsequence of at least length 1. So I just choose length 1 every time. So if you have a duplicate, then I take one of the duplicates, because that's going to be cool, because the only average is the value itself. And if that's not in duplicates, then it's never possible, because a subsequence of length 1 of the subsequence, that any subsequence you choose, would not be present in the complement subsequence. So that's what I did. And what was overwrite? Right. So since the elements are distinct, and it will be always be optimal to replace it with the lexicographically minimum cyclic rotation of B, what I did was I found the first index such that the character in, so it'll be better if I show it in as a code. So I try to find the first index such that A is greater than the lexicographically smallest first character of the lexicographically smallest cyclic rotation of B, which is also the smallest letter of B, smallest rotation, smallest integer of B. And if that, and I find the integer in the range such that I can still fit a array B starting from that index. So I go only up till I plus m minus 1 is less than n. So if I don't have such an index, then I compare between the normal one versus the normal one with the last m integers replaced with B, and whichever smaller I return. And if m size is greater than 1, then starting from the first index such that the first that I am making an improvement. I put a array of b zeros because b1 will always be greater than b0. So once you fit a array b, the character right next to it will be greater than b0. So it's optimal to fit a b again, and I keep doing that until I can't anymore. And whatever smaller I print, this is not required, but just for safety. And the last is if m is 1, then I only replace the character which are lesser than b. Now what was d? But D was interesting. So I just guessed that maybe it's always optimal to only. So after the first and second people have sat, so that's always optimal to for them to sit in the endpoints. It's optimal to check if the other integers, other people have sat in the seat that maximizes the primary goal, and my guess was secondary goal would automatically be satisfied, and that turned out to be true. So I found the simple relation between length of the boundary. The such boundary is the subarray for an index such that maximal subarray which starts and ends at occupied seats. Like minimum length maximum subarray that contains the index and starts and ends at the occupied seat. So I only start looking for it after 1 and 2 have sat at the extreme, so I'm guaranteed that it's also occupied. That always exists. So for indices from 2 to n minus 1, what I get is the indices I've chosen by looking at the inverse permutation. Then get L and R to be the bounds, which I do with a simple binary search in a set of indices that have been occupied. And get the biggest one. And since the distance in the biggest interval will always be so the distance function from integers from length of subarrays to the minimum distance is a monotonically non-decreasing function. So to check if the current distance is optimal, it's good enough to just check if it matches the biggest. So first I check what's the biggest right now. Then I look at the curve size, which is r minus l plus 1. Then I check if the distance is not equal. If it's not equal, then I'm not choosing the optimal one. Then second, I have to also check if the index I've chosen in this distance is the middle one or not. So I did that by taking the mean distance for both the intervals and seeing if it matches the distance of the curve size, which if not, I return no. Then I erase s from that and replace it with the children as long as the lengths of at least 2, because if it's an interval of 2, that means the 2 occupied seats are adjacent, so there are no free seats left in this interval. And then I output yes. Now E was again, I had an observation that if all the subsequences of length 2 are present in of A, there are just present B, then B would be B's length would be almost the square of A's length, and since B is constrained to be about 2e5, that means if all of 2 is present, then A would be at least root 2e5, and as you increase the length, it becomes B length of B to the power 1 by k. So my guess is brute force should pass, and I just wrote a recursive function which goes to all subsequence of a particular OG length and checks the sum. Once I've taken all the n of length, I check if one is divisible by length, or if it's present in B. If any of these conditions fails, it's not present, and then I have a method to backtrack and find the subsequence which led to this, and I print it. And F, I have no clue, but it looks like the condition that that's mission problem is true, but I don't know why. And yeah, let's see. I'm curious to what the editor will say. What's the final rank? 53. Not great. What's the delta? 2122, and I started at 2122. Okay. Plus 40 is plus 50 is fine, I think. All right. the stream.